Hi, good
Hello.
afternoon, good morning, good evening, everyone. Thank you for joining this call. I hope you can hear me. Could somebody just put in the chat that they can hear me? All right, with that, we can get started. My name is Amit Dingare. I'm the Director of Data Science and Insights at Novelis. For those of you who don't know Novelis, Novelis is an aluminum rolling company, and I'm going to talk quickly about us. So we produce the flat rolled aluminum coils. We are the world's largest recycler of aluminum. Aluminum is one element that can be infinitely recycled theoretically. So we basically recycle aluminum cans, beverage cans, or any other aluminum scrap and then create new coils. So what you see on the right hand side is our end product that basically we produce, and then we supply those flat rolled aluminum coils to four main segments: aerospace, automotive, can, and specialties. And at the right hand bottom, we have some of our customers. So there's a good chance that many of you have actually interacted with our aluminum. You just don't know that it's coming from Novelis. So you might ask, what is the point of a data science and insights team at a aluminum rolling company? And this is where I'm going to surprise you, I guess, if that's a question that is coming to your mind. But before that, let me just quickly talk about the company. We are a global company with 15,000 plus employees in 9 countries, and we have 33 plus plants. So my team, which is part of the Digital Center of Excellence, we focus on um, two main areas: operations and supply chain, although we are expanding into other business functions. And our focus historically has been on applying advanced analytics techniques such as machine learning, linear and nonlinear optimization, simulation, and statistical modeling to solve business problems. So in a manufacturing company, you have many machines, and thanks to Industry 3.0, a lot of those machines have been sensorized. So for a long period of time, the industry is collecting large amount of data. Historically, that data was largely used for dashboards or reports, but with the advent of AI and ML, now we are actually making much wider use of that data to generate insights. And I'm going to talk about one use case that we have done today. The two things that my team cares about is generating value and building capabilities in our plant. And while this particular visual shows that those two things are equally important for sustainability of our use cases at Novelis. So we have goals that are focusing on both those areas. So how do we work with in manufacturing? As you know, the industry is quite old, especially aluminum rolling company. Industry is about 250 years old. So naturally, as a part of that, the data is quite siloed. It's captured in various systems. You have historian systems, you have manufacturing excellence systems, SAP or ERP systems. So you basically have data captured in multiple different places, and historically people were not able to use that data. So what we do is, once we get a problem, it could be a problem on improving throughput, it could be a problem of reducing downtime of machines, improving quality of our parts. um, any kind of problem that we get, we start the solution with the source data. And this is very important point. In many companies I have seen that they first focus on the number three item, where data engineers get involved, and then they build pipelines to bring that data in data lake or some data fabric. Then now there are like several different acronyms for the storage place, and then data scientists start use cases. We have flipped that equation a little bit differently. What we do is we start the use cases with the source data, and once we start seeing value from that use case during the proof of concept phase, then we work with our data engineering team to bring that data in a centralized place to then create a production ready and sustainable AI ML model. The advantage that we get with that is typically, especially after COVID, people have much shorter expectations in terms of value. And if you take too long to get the data and create value, people lose interest in the use cases. So to keep that business interest going, you need to attack the problem quickly and show some value in the first 6 to 8 weeks, and then you can think about creating a sustainable solution afterwards. So that's something that I would say is a critical thing. And then we have several people basically placed in different regions that work on getting that option and change management around our use cases. So we have done quite a few use cases in the last few years, and I'm going to talk about one such use case where we have used data science to augment decision making that happens in shop floor. And to start with, I'm going to show you how our machines work. So this is a cold rolling operation, and our coil is coming from the machine. And as you can start see, as you'll see, you'll start seeing those issues on the coil. And these issues come because the operators have not entered correct parameters. Now this is what we call as bad start. And to basically, in every machine, the operators enter various parameters. In this particular machine, they enter 4 parameters: the tilting and bending for the work rolls that basically apply the force on the rolling mill. And if you don't enter those parameters correctly, you go into this bad start, which ultimately results in um, bad starts and then downtime. So the goal behind this use case was to cut down that downtime. So basically, the solution that we thought about was building a machine learning model that we can build in cloud and then deploy back to edge, and that machine learning model creates or provides recommendations to operators for the entry parameters that they enter. Right. Historically, those entry parameters are entered by operators based on their intuition and knowledge about things. So there are a few constraints that we had. There is a pretty small gap between two successive coils, so we had to do these predictions in 135 seconds. And in doing those predictions, we have to take data from the previous machine, how the coil came out in the upstream machine, and combine that data with the condition of the current machine for the previous coil. So we have to join those two data sets and then create features, and then ultimately you apply ML models on top of that to get predictions, and then send those predictions back to the operators on the screen. So we went through a lot of data engineering work to get to that point, and to be able to take the model and make it fast enough to do the predictions in 135 seconds that we have. So, the model now basically gets data from previous coil, from the previous machine center. We join that with the again the machine condition, and then we do those predictions, and those predictions are then sent to the operators through the HMI. So what you see on the right hand side is where the predictions are sent to the operators, and now the operators have the ability to either use our predictions or decline those. So they can always override those predictions. So this is all done by the data science team. And what we found is once the operators started using our predictions, that reduced the downtime by about 70%. So this project created huge value, and this is one area where we are seeing a lot of traction right now. Is how do we apply AI and ML to augment operators' decision making? But like any other industry, manufacturing also has the curve of change management, right? For any technology change, you have to overcome that change management. And here is a pretty good visual that depicts what that change management looks like in a traditional manufacturing company, right? The technology is changing very, very fast, as you all can imagine. But typically, when you have organizations, and especially big organizations, they take long time to make that change, right? So then you create this gap between the technology change and the organizational readiness for that change. So to overcome that change, you have to do some dedicated change management efforts. And I can't undermine this particular fact that change management is extremely important for successful adoption of technology in large organizations. So I'm going to actually I really like this particular concept that Gartner has put in terms of how do you influence change management. So this is a Gartner's framework, but I would like to added my own thoughts on top of that, and I would like to make it available to everyone listening to this presentation today, because the this particular framework is applicable in every industry that you work in, no matter whether it's manufacturing or any other industry. And what Gartner says is there are four types of personas in a typical organization. You have the runners who are always excited about new technology, new change. They always see glass half full and always ready to try things out, right? So these are your champions. So you have to always first identify those champions when you are trying new things, right? Once you kind of get them on your side, the next group that comes is called joggers, and they will join your effort once they see that runners are joining, right? So getting the runners on your side is the first step. The once the joggers see that runners are actually running, they start supporting your initiatives and kind of get part of that larger change effort. The third is a walker group, right? They are not as easily persuaded by the early adopters, the runners, but they need to see some successes before they chime in, right? And in that particular case, you have to do a dedicated effort to highlight the successes. You have to do formal presentations, talk to the people, maybe do lunch and learn sessions, invite them, just show them that this transformation is working, it's producing value, and once you start doing that enough, these people will start coming behind you, and now you have large amount of mass that's part of the change management effort. And then the last group is the sitters. In that particular case, Gartner recommends that you can perhaps use the executive mandate to get them on your side, but when you have the large enough critical mass on your side, that typically should be good enough for succeeding for that successful change or transformation. So with that, we have 2 minutes, so I'm going to quickly talk about the key takeaways from today's session. One is manufacturing. As I see, I joined this industry manufacturing just 3.5 years ago, but I'm seeing that there is a transformation going on in the industry, and lot of that is driven by the advent of Industry 4.0. Definitely look up this term if you don't know what that means. But I would say that advanced analytics is becoming a very big agent of that change, of that transformation. There is a lot of value that you can uncover using advanced analytics. I mentioned this earlier, but you should focus on speed of creating the value in the initial stages, because you want to make sure that the business and executives are behind you. If you take too long, then people lose the interest and they move away. So creating value quickly is very important. And to begin with, you can choose use cases that augment the human decision making, right? So humans get fatigued, they get tired, and many times we make poor decisions. But if you have some kind of a system that you can rely on in those cases, it really helps. And this is where you can start driving the change management as well. And never underestimate the change management effort. It's one of the most important things that happen for delivering value from advanced technologies. So with that, I want to thank you and happy to answer any questions you may have. Okay, if there are no questions, my email is here. Please feel free to reach out to me if you have any questions. But I appreciate your time today. Thank you.